Hello, it's Uncle Ben. Today is Tuesday, March 21st. It's about 4:30, and I don't have anything major to report on, but one of the things that have been happening in my life is yesterday I had a lab meeting with the brain lab. The lab was canceled, but in its place, Professor Fong, the primary investigator for my lab, she encouraged us, strongly encouraged, as in, you really should go. But a lot of members of the lab went to a talk from a professor from a computer science department, I believe from the University of Michigan. And by the way, right now we are having lovely weather. I am here at 4:30 wearing a jacket in April. So, yes, it has definitely cooled down. It's about 65 right now, so it is great weather. I'm really excited to go running later today. Hopefully we'll do trails, but report on that later. So, this researcher from the University of Michigan is doing research into the brain, and specifically how similarities between modern computer modeling and how something called feature extraction. So, for example, what our eyes do, what our brains do, is we see an image and we're able to say, yeah, this is a face, these are sunglasses, this is a hat, this is a logo as a part of a jacket that's on top of a shirt that's on my chest. Well, how does our eye segment those things? And can we use that to inform our computer modeling? Because the brain is a very powerful instrument for determining the identity of things with relatively little programming. As far as once you learn something once, you're able to identify it again and again and again and again with very high accuracy. Now, some people are better at that than others, and of course there's the whole cognitive element. But as far as see something and recognize that you know it before, so like taking this out of context, if I don't show you the rest of the tree, you can tell, yeah, that's a branch. It is very hard to get computers to know that. So, that's one of the things that he's working on. And apparently, the algorithms that are currently being implemented, algorithm might be a wrong term for it, or not the greatest term for it, but the current best method for computer learning, if you match that up to the brain signals that you can measure in someone's brain, actually specifically I believe the occipital lobe down back over here, which deals with vision and image processing, apparently there are parallels between the two. Additionally, in one of my classes, junior design, we just got the presentation on our third project. Our third project is going to be solving some sort of problem, which we have to decide what the problem is, but the problem this time around is in traumatic brain injury. And so one of my professors that I had last semester, Professor Gundez, had a traumatic brain injury on a bike, and that was March of 2020. And there was some other thing that happened this past fall. We don't know if it's related. I, as a person, do not know if it's related. But basically, this panel and these professionals were talking about different problems that need to be solved in the brain injury area. And that's kind of a complicated area. And even them talking to us where we knew generally what was going on, a lot more than the average person would know of like jargon and specific terms. It still came off as very vague and hard to follow exactly what was going on. So, one of the things that I've thought about in relation to that is one of the professors that were talking about brain injury. They study brain injury in some capacity. Sorry. There's a bug on my hand. They were commenting on how the modern advancements in technology, such as Bluetooth, and basically the level of processing that's on your phone, hasn't really made it into the clinical space yet. So, clinical space being doctor's office, operating room, especially emergency surgery. There's a lot of the conveniences that would increase the effectiveness of treatment that just aren't being applied yet. And also, since basically all this has gotten me thinking about how modern science is so for modern science and the perception of science puts a lot of emphasis on making new discoveries, breaking new ground, being at the forefront of one's field. And there's a stigma to doing supplementary work. Even though supplementary work and going back over other people's experiments and retesting and fleshing out everything, that is where it starts to become relevant to the public. For example, the brain scanning tools that were being used in the computer science study, they're able to track the pathways of neuron firing. So basically what parts of the brain are talking to what other parts of the brain. That would be really helpful in diagnosing brain injury because there are certain pathways for how the brain thinks. Sorry if there's some wind noise here. The wind just kicked up a little bit. But if we're able to study the brain in those ways, it's more of a fact that while knowing how the brain works is amazing research, if we're not able to connect it to real life problems, then to be able to solve problems and increase the quality of life of either those who have had injury, will have injury, to potentially prevent injury, those kinds of things really give science its appeal for some people. Now, science for curiosity's sake is completely valid, but we are at a point in our society in which we have a limited amount of funding, but lots and lots of tools for discovery that have been introduced over the past dozen years or so, the past 12 or even 20 years. The digital revolution has revolutionized our ability to work with massive amounts of data, and also has increased the ability for people to talk to each other. The professor from Michigan, he was talking to us. He gave us a presentation. He came the day before on an airplane and is probably back in Michigan. Will probably be back in Michigan by tomorrow. While that was able to be done in earlier times, the ability to do that is so much easier nowadays, making connections between people. And I think that's where science really needs to increase, needs to do a better job of. Personally, from my viewpoint, science, one of the biggest limitations right now in science is the lack of communication. Now, science communication is far better than it was 20 years ago. But if we want to keep on having the same advancements in science as we've had in the past 20 years, we need to redouble our efforts of cross-pollinating ideas and information and discoveries across different sectors. Because computer science can shine light on what the brain is doing, and our knowledge of the brain can potentially be implemented to increase the efficiency of computer science studies and big data. So, yeah. It goes to the theme of, it all works out to the theme of talk to people. People are very interesting. And most people who you will come across will have some other perspective on the things that you're doing. Or, which goes in reverse, you might have a perspective on what they're doing. But if you two never talk, then that will never be discovered. And therefore, there'll be wasted time and energy, and also just wasted experience. If someone never puts out their ideas, then society is all the less for it. But conservation for conservation's sake is not always good. One more thing before I wrap up. I am here at this trail entrance, which is like a mile-long trail around here on campus. The baseball stadium, the UF baseball stadium, is over that way. And the Museum of Natural History and the Art Museum is over that way, past the generators. You can kind of see it right there. But stuff like this trail system is a good example of allowing conservationism to have meaning. If you have thousands and thousands and thousands of acres of protected land that no one will ever set foot in, what's the point? If we're able to experience nature in a way that doesn't disrupt it, those practices should not be hindered at all. Me being very biased as being a trail runner, something where besides the one little foot wide path that I have, I don't need any other editing of the surroundings. And so, yeah. Just like with conservatism, or conservationism, not conservatism, just like with conservationism and with science, we need to be thinking about not only why we do it, but how is this actually helping? Are we advancing? Advancing is good, but we need to make sure that the stuff that we've already done has been vetted and has been used. Cell phones are great, but if you don't use them to contact people, then you end up just as lonely as you were without them. And so, that all being said, we need to make sure, as a whole, of communicating with each other. Like this, hopefully. Anyway, I've been Uncle Ben. I love you. I'll see you next time. Bye.